Good morning, students. I am Dr.Helan Rathi. Now we will study about moduli of elasticity. First of all, matter exists in any one of the three states, namely solid, liquid, and gas. In solids, atoms or molecules are strongly bound to each other and are almost fixed at their positions. In liquids, atoms or molecules are not bound to each other as strongly as in the case of solids, and they are somewhat free to move inside the whole mass of the liquid. In gases, atoms or molecules are not bound to each other and are completely free to move around in the entire volume of the container. First of all, we will learn elasticity. What is called elasticity? When an external force is applied to a body, there will be some change in its length, shape, and volume. When this external force is removed, and if the body regains its original shape and size, then the body is said to be a perfectly elastic body. If the body does not regain its original shape or size after removal of the applied force, then it is said to be plastic body. So, in fact, the property of elasticity is different in different material. In fact, there is no body in nature which is perfectly elastic. The nearest approach to be a perfectly elastic material is the quartz fiber. Solid substances like rubber, metal crystals are examples of elastic bodies. Plasticity body, if the body does not regain its original shape and size. There are three types of stress and strain. First of all, what is called stress? When an external force is applied to a body, it gets deformed. Then the forces of reaction is set within the body to restore the body to its original condition. So now we will study the definition of stress, that is the restoring force acting per unit area inside the body is defined as stress. This restoring force is equal and opposite to the applied force F. So stress is equal deforming force divided by area, that is F by A. SI unit for force is Newton and area is meter square. So SI unit of stress Newton per meter square, otherwise Newton meter power minus 2. Types of stresses. It's found that the deforming forces may change length or shape or volume of the body. Accordingly, there are three types of stress, namely linear or longitudinal stress, shearing or tangential stress, and volume or bulk stress. Now we will go through strain. What's mean by strain? The change in dimension or shape of a body due to the deforming force results in strain. The strain is measured by the ratio of change in dimension to original dimension. That is, strain is equal change in dimension divided by original dimension. The strain has no unit since it's a ratio of same physical quantities. What are the types of strains? According to the changes in length or area or volume, there are three types of strain, namely strain, shearing strain, and volume or bulk strain. What is deforming force? The force which changes or tends to change the shape or size of a body without moving it as a whole is called deforming force. There are three types of elastic modulus. That is Young's modulus, rigidity modulus, and bulk modulus. First of all, we will see shear modulus or rigidity modulus. The rigidity modulus of elasticity is denoted by the letter N. Within the elastic limit, the ratio of the tangential stress to shearing strain is called rigidity modulus of the elasticity. Already I told it's denoted by the letter N, that is rigidity modulus, otherwise shearing modulus. N is equal tangential stress by shearing strain. Shearing stress is equal F by A. So, this rigidity modulus of elasticity N is equal FL by AL. Next, Young's modulus. Within the elastic limit, the ratio of linear stress to linear strain is called Young's modulus of the elasticity. And this modulus is denoted by the letter Y. That is, Y is equal linear stress by linear strain. Already Robert Hooke, an English physicist, in the year 1679 had given a relation between stress and strain. That relation is known as Hooke's law. That is, stress by strain is equal to constant. That constant is called modulus of elasticity. So, modulus of elasticity is equal the ratio of stress and strain. Young's modulus of elasticity Y is equal FL by small a into small l. SI unit of stress already we have studied in m power minus 2. Strain has no unit, so SI unit of Young's modulus of elasticity is Newton meter power minus 2. The same unit have rigidity or shear modulus. And the third one, bulk's modulus, that is denoted by the letter K. Within the elastic limit, the ratio of the volume stress to volume strain is called bulk modulus of elasticity. So, bulk modulus K is equal volume stress by volume strain. That is, K is equal to PV by V. The unit of bulk modulus of elasticity is Newton meter power minus 2. Some applications of elasticity to bending of beams. A beam is a rod of uniform cross section which is used to support heavy loads. Depending on the shape of the cross section, beams are called rectangular, circular, I-beams, etc. Based on the type of support on the ends, beams are classified as the cantilever type, simply supported type, fixed ends type, etc. When beams are loaded, they bend, and consequently bending moments and bending stresses are set up in the beam. Using the concepts of elasticity, bending moments and deflection of beams can be correlated. Next class we will see about bending of beam, that is what is called girders. What are the applications of girders? Thank you.